Hi, welcome. I'm Kimberly from the Country Bookshop, and I want to thank those of you for who are joining live for your patience and your desire to stick with us as we work through some technical difficulties. I want to begin by saying a little something about the Country Bookshop. We are located in Southern Pines, North Carolina, and we're established in 1953. We are owned by the Pilot newspaper, and you are welcome to buy books from us online or in person, especially the book we are here to talk about today, The Edge of Space-Time, Particles, Poetry, and the Cosmic Dream Boogie with Chanda Prescod Weinstein. The Country Bookshop's purpose is to ignite ideas and connection through conversation with each other and idea generators, like some of the authors we have hosted in person: Scott Pelley, Amar Tolles, Tui Sutherland, Jason Mott, John Meacham, Kate D. Camillo, Kwame Mbalia, and people who cannot join us in person but are so willing to give us their time, like Dr. Prescod Weinstein today. Um, Let me begin by introducing her. Chanda Prescod Weinstein is an associate professor of physics and astronomy in core faculty in women's and gender studies at the University of New Hampshire. She conducts award while also researching Black feminist science, Disordered Cosmos, A Journey into Dark Matter, Space-Time, and Dreams Deferred, won the 2021 Los Angeles Times Book Prize in Science and Technology, the 2022 Pi Beta Kappa Award in Science, and a 2022 Penn Oakland Josephine Miles Literary Award. She's a columnist for New Scientist and Physics World, is originally from East LA, and now divides her time between New Hampshire Seacoast and Cambridge, Massachusetts. So thank you so much, Shonda, for joining us. You might need to unmute to chat.
Thanks so much for having me.
Yes, I mean, thank you for writing this book and translating these ideas and making it just so easy. And especially thank you for letting us do a two-part series here at the Country Bookshop. The first one, as you know, is with your editor and author, Nicole Chung. And we're kind of looking at that as an introduction before you read the book. And then this conversation kind of functioning as a bit of a conversation to help guide the discussion. Uh, um, for what happens at the boundaries of a system, and that tells us what's possible in the other aspects of the system. But the book's been out for like 2 months now, and I know sometimes author, and I'm wondering now that we're having this discussion after you've had feedback from the community and more readers, if that has changed for you personally.
So I will say, for some reason, the internet cut out partway through your question, but I think the question that you asked was how my relationship with the book has changed as the book has gone out into the world over the last 2 months.
Yes.
Yeah. Um, this book in particular caused me a lot of anxiety in a way that I wasn't anxious about my first book. And my first book, I think as a first time author, I knew not necessarily, I had the mindset of I can't necessarily expect too much about how the book will do. And um, I was kind of like, I don't know how the book is going to be received. But then also, from the trades, got these starred reviews very early. And so I was able to go into release day with the confidence that it was at least being well received critically. And then as I watched that book be out in the world, I saw a lot of the reason that people were picking it up was because there was something that they appreciated about the problems that I was raising about how physics happens and how the physics community is organized. And I think that that was good and important work. It was also like the book had the subtitle Dreams Deferred in it, or had the phrase Dreams Deferred in the subtitle, because the book itself represented a dream deferred for me. Like it wasn't like my dream in high school to write a book about what's wrong with physics. It was my dream in high school to write a book about physics and what's exciting about physics. And so I think actually one of the tough things about having a book like that in particular that was well received critically, to then go on to write a book like The Edge of Space Time, is there's a lot of anxiety that comes with, will the audience accept me actually focusing on things that I like about physics? And will the audience accept me doing that, particularly in this political moment? And I think there is also, we do have a cultural problem in the United States that people like to consume Black pain. And so I do think that there was sometimes an element of that was part of what people enjoyed about the disordered cosmos. And so there was a lot of like, oh my God, what if people don't accept me being in Black joy? And that's part of what the book is being in Black joy. And so it has been really nice over the last few months to see that there is an audience for the book and that people have understood the work that I was doing with the book. Like, I actually do really feel understood. And in a way, for me, The Edge of Space Time is a much more vulnerable book than The Disordered Cosmos was, because The Disordered Cosmos was really like, these are the things I can't get away from, but The Edge of Space Time is my heart. And so it's a lot more vulnerable to talk to people about, like, these are the things that really matter to me. These are the things that make my heart sing, and to really fill a book with that. And also this is like the weird way that my brain puts things together and processes things. So I will say I had like a very like kind of love-hate relationship with the book as we went into beginning promotion and publicity, because I was so scared of how people were going to receive it. It was certainly the case that the trades didn't respond as well to the book as they had to the first one. And I do genuinely think if you look at the pattern, when it comes to Black authors, they like us talking about what hurts. And they simply just don't review us as well when we talk about what we enjoy. So that's been a lesson for me also in the disconnect between like what professional reviewers try to steward readers toward and what readers will read when they're given the opportunity. And so I think that that's something that's also been a learning experience for me.
I think that is really, really interesting to me, especially in the context with which I come to the book, in which I bring the country bookshop audience to the book, because it is fully because I am so curious about the way you translate these ideas that are mathematical and abstract into words and metaphor, because that is how, for people, for me, for readers, how we can enter them. And so we get to enter them through your metaphor, through your queer feminist lens, as the only way I think many of us will ever encounter these ideas, which is interesting in the context of how you just answered that question, for how it functions for this audience in particular. Um, I'm going to kind of skip through a few easy questions. Well, actually, I will.
I'll take easy questions.
Okay, okay. Well, um, you might not say this easy, but you talk about, but the physics thought landscape today. You wrote the book much further than it came out the 2 months ago, and in it you talk about a few things like that. By the time it comes out, the Nancy Grace Roman Space Telescope will be launched. You talk about different collaborations and working groups, and you talk about some labs that had been closed, and physicists who are talking about different things. Can you just, today is June 3rd, 2026. What is the general landscape of physicists and what they're studying, and what, just for the lay person who doesn't have any context at all?
So the challenging thing with the Nancy Grace Roman telescope is that while I was working on finalizing the book last year, um, the Trump administration tried to cancel the project. And so there really was kind of this thing of, I'm going to write about this in the book. And I don't know if by the time the book comes out, we will still be in the planning phase for a fall 2026 launch, which was what the planned date was last year. And it's actually the case that the launch has been moved up. So it was supposed to be in October at the time that I was writing last year. Now it's going to be in September. And we have the project is going forward. The instrument, I think, is about to, like, sometime in the next couple of weeks, begin its journey to where it will actually launch from. They've wrapped up testing, and it's very exciting. but it is one of those things, like the hard thing about writing a book that touches on contemporary issues is that at some point the book gets frozen for various reasons. And some of that has to do, like, it gets frozen in a big way because the book has to be indexed. So if a book has an index, that means that time was needed for the indexer to actually make the index. You can't change pagination once that process begins. So you can make small changes where the character count remains the same and you don't affect where things are on the page, basically. Um, but so that was, I think, one of the challenges that I faced. And really, by like November, I had to kind of accept like what the book says, this is what it's going to say. And then like there were certain places that I could make changes. In terms of like the science in the book, I don't think that like anything that I said scientifically in the book is out of date, happily. Like there was no, it wasn't something like I wrote this whole book and then like the day after it came out, like we figured out what kind of particle dark matter was and it totally like screws up that entire chapter about like all we can never know or anything like that. Or all that we can never see. So I think that, but that is like, I think in terms of taking the long view with a book like this, I do want it to be a book that hopefully in 5 years people will still see value in reading. And so there is kind of a thought of like, how do I make the book robust against the changes that are going to happen scientifically? Forget like the policy changes that are going to happen to science, but the things that we might learn about the universe between now and then, so that the book will still be like interesting and readable to an audience 5 years, even 10 years from now. Um, and so I do think that my latest New Scientist column, which will come out next week or the week afterwards. We recently changed publishing timelines, so my sense of like when things are is about how I think 2026 is the year of the galaxy. And so I don't mind that I kept some focus on galaxies, particularly in the astrophotography chapter of the book, because between the Nancy Grace Roman Space Telescope launching and also the Vera Rubin Observatory starting its 10-year legacy survey of space and time, it's basically getting that underway right now. Those two projects in tandem with JWST, which is doing amazing observations of galaxies, and also Americans might be less familiar with the European Space Agency project Euclid. The Euclid is kind of the European Nancy Grace Roman Space Telescope. They have very similar mission directives and the instruments have some overlap. All four of those projects together are just going to give us so much new information about galaxies, particularly over the next 5 years, 5 to 10 years, that I expect we will have a very different understanding of like what a galaxy is and where it comes from, like really its evolution. So I think that is a thread that I don't pull very hard in the book, but that's something that I would encourage people to kind of keep an eye on because I think it's a very exciting time for it.
Well, I appreciate that direction. And also what I love about your book is it would set up any reader to then receive that information, which is what I'll kind of dive in now. And just for everyone, I'm going to reference like page numbers just because our book clubs like use these. And I'm using the hardcover first edition of this book. But I'm curious about and this is like a tiny thing, but the photons on page 181, you say like it's in the footnote thing that we refer to them by their energies and sometimes by their wavelengths or frequencies. And you say that this is cultural and we can convert between them. And can you explain the cultural context for this? And who is we and what are these cultures and why are they referred to in these two different ways based on the cultures?
Yeah, I love the level of detail of this question because it allows me to get into some of the nerdy stuff. So, um, as I described earlier in the book, in Baby's first field theory, light is part of the electromagnetic spectrum, and so there are different wavelengths or frequencies. So I will start by saying, so wavelength is literally like how long is the wave before it repeats, right? So waves repeat and basically like how long is the wave before it repeats. So you can think of this as like an extent in space. It's literally a length. And the frequency is like how many times in say a second. You have to pick like a time scale, but how many times in a second does it repeat? So you can see that the wavelength and the frequency are connected to each other, right? Because if you have a certain wavelength, you're also going to have a certain frequency associated with it. And then the energy, it turns out, because of quantum physics, and this is something I also talk about earlier in the book, that there is an energy associated with every wavelength or every frequency. The part where it becomes cultural, so that's just the physics. They're all equivalent. So there's an equation that makes it easy to exchange between one or the other mathematically. Where it becomes cultural is that it depends on like what area of astronomy you're in as to whether people are using wavelength or using frequency or using energy. So on the high energy part of the electromagnetic spectrum, so things like X-rays and gamma rays, so these are types of light that are produced by astrophysical phenomena but are blocked by the atmosphere. So if you want to look at X-rays, if you want to look at gamma rays, you have to go to space. So we have space telescopes that do these kinds of observations for us. So usually in X-ray and gamma ray astronomy, we refer to light in energy. So you say like I have like a zero point 0.5 keV photon. So keV is kilo electron volts. That's an energy statement. Whereas if you go in the opposite direction to, for example, radio astronomy, which is very long wavelengths. So high energy, the wavelengths are very short. But if you go to radio astronomy where the wavelengths are very long, then people tend to talk about things in wavelengths. So there's like millimeter astronomy, and it's literally got millimeter in the name. So millimeter is a reference to a wavelength. So and then you have things like say optical astronomy, which is light in wavelengths that we can see with our naked eyes. And there you'll see that people may use frequency, they may use wavelength. There's kind of a back and forth. Similar with like ultraviolet light, you may see it in frequency or you may see it in wavelength. I will say, like, I think wavelength is probably more common, and it's really like, is it wavelength or is it energy? But that's what I meant by cultural, is that this is really something that has to do with like what kind of research you're doing that will determine what language you use.
Which is super interesting in the context of your book because the whole thing is using different language to say the same thing
Yes.
over and over. Um, I I want to look at and hold on, let me highlight some of these questions I'm skipping in case we go back. I want to turn now to the idea of the observer being in conversation with the observed. You Some of the things you talk about, like Catherine McKittrick's work and Night Flyer by, is it Tia, Tiya?
Taya Miles, I believe.
Taya,
Taya Miles.
Taya
Yeah.
Miles. But you talk about your love for astrophotography and the way you start to feel like the rhythms of the universe on page 179. And I love that because it highlights how we're in conversation. And I'm as I'm reading your book and thinking about the conversation, I'm wondering if you can like, you know, color this in for me about the Stern Gerlach experiment and this observed, which this is the first time I know about this, but this observed thing and like how that's like a one-way thing and not a two-way thing. Because, you know, it's like conversations. And I love you talk about John Bell's response to that in like chapter 9 and later on 256. But, and I'm quoting you here, but he was deeply troubled by the conclusion that the observer could actually cause a system to select a status as if the universe were simply waiting for us to come along and look at it. A complete theory of quantum cosmology will be able to navigate the unique way this measurement problem manifests when trying to cover the entire universe, observer included. And I'm just like, I feel like in everything's in conversation with itself, like in motion and breath, like in ecosystem, and in the way that the observed is acted upon by the system. Doesn't it like have to be both ways? And I'm just wondering, how the conversation works within that experiment.
Yeah, so I think so the Stern-Gerlach experiment, which is one that actually usually physicists are like, we don't talk to the general public about that because it's a little bit of an elaborate thing to explain to people. Because when you have to give people a sense of what a magnetic field is, you have to give people a sense of what momentum is, and then not just momentum, but angular momentum, right? And you already have to give people a sense of like what they think atoms might do versus like what atoms actually do. So a lot of the first half of the book is actually setting up, let's talk about this experiment. And then having faith in the reader that, okay, like I'm going to hand you something that brings all of these pieces together and show you how physics synthesizes in a way. So the Stern-Gerlach experiment really shows that when an experiment has some kind of observation happen in given very specific conditions, so the very specific conditions of this Stern-Gerlach experiment, that a particle that had a piece of information may no longer have that piece of information to reveal to an observer. And I think that one of the key takeaways from that, I think it's easy to walk away from that thinking that that means that the observer has to be a person or a sentient being. But actually, what we're talking about is it really could have been like um, you send an electron in, and the electron is the observer, right? And that's not a sentient being or anything like that. Um, so it is not anything to do with us as people, our humanity, or sentience, or anything like that. It has a lot more to do with when the particles are no longer contained in a particular way and isolated from an outside observation. But I think this really calls on us to rethink our understanding of like what constitutes an observation or an experimental interaction of some kind. And so it allows us to start thinking about generalizing our sense of like what it means for a system to interact, that doesn't necessarily mean that there has to be a person there. We do have kind of these larger questions there that, of course, we do observations all of the time, people, animals, etc. And we somehow live in this world that is largely deterministic, but kind of emerges out of these processes that are not deterministic. And that's actually an unanswered question in the book because it's an unanswered question in physics, which is like, how do you get this deterministic world out of a non deterministic set of phenomena? And I think that that's supposed to feel confounding. It's supposed to be confounding because if you as the reader feel confounded by it, then that means you're starting to have a sense of like where we are at the edge of our understanding of physics and how the universe works.
Well, that's the invitation, and I think that's the beauty of this book is that you explain
Thank
everything
you.
so well and like take us there. And I think this surprise and wonder and awe and imagination that you bring to the reader, but also talk about how that is a core element of being a scientist, is part of what makes your book so beautiful. And it's the experience of reading the book and being exposed to these concepts for me as a reader, very much for like the first time, although I see echoes like seriously obvious anyway. Um, I think it's beautiful because the structure of it and the way some of the things you're doing, like literary or magically or something, seems to correspond to like the quantum nature of stuff you're talking about. And I just love it. And I'm gonna read something that you wrote in there that is very vulnerable. It's towards the end of the book, and um, I'm bringing it up with reverence to the fact that you are talking about the pain of the moment that you're writing. But this is on page 297, and you say, "I'm weeping in my now. I hope I am not weeping in yours. I write to you from a past that I hope feels distant to you so that you can learn from our conditions and ensure you never find yourselves in them. And I, in another part of the book, you talk about how you read Isaac Newton for the first time, like directly in preparation for this book, and that you start to engage in conversation with him over time, like with one paragraph that you didn't like, that you took issue with. And as the reader, I'm like, oh, and we're having these conversations through telescopes and light over time. And I just want to ask you a little bit about that experience and just, it's an open-ended question with those little points to.
Yeah, sure. I mean, as I said in my answer to the first question, like I knew the book was going to emerge in a particular political moment. And, something like this doesn't get drafted in a year. And so I wrote the first draft of this book and actually turned it into my publisher in July of 2024. And so this is before the fall of 2024, before the election, before the inauguration, before the very dramatic changes to American science that have been happening over the last year and a half, and the attacks on American science that, like, honestly, I think if like you really hated the United States, you would do the kinds of things that are happening to American science right now. Um, so, I mean, the enemy within, hey. And so, but at the same time, when I started the book, um, October 7th had already happened. And I was very aware as within days of October 7th happening, I had a pretty good sense of like how Israel was going to respond, that there would be collective punishment to the entire Palestinian population for the actions of what was, relatively speaking, a small number of people. And I think we can feel real grief about the lives lost that day. And I'm a peacenik, so I'm very much a like beat the swords into plowshares kind of person. And at the same time, recognize that October 7th isn't the day that history began and that Palestinians have been living in under an occupation for the better part of a century now, and that violence begets violence, and that Palestinians have been living in violent conditions for decades. And so there was this feeling of like looking around and thinking like, my life has gone on while lives are being ended. And at the same time, like reading about, for example, the Gaza Astronomy Club, there was an amateur astronomy club, and wondering, are those people alive? Do any of them still have any of their equipment? And I've seen photos of the Gaza Amateur Astronomy Club, and they had telescopes that are not cheap, even by American standards. So it must have been extraordinarily difficult to acquire for them. And they had the added layer that they had to be very attentive to when they went out and did observing, because there was always a risk that Israel Defense Force fighter jets would think that they were weapons and not objects for observation. And so these were people who literally took their lives into their own hands because they wanted to look at the night sky. And so there was an element of wanting to honor where that comes from in people, and recognizing the legacy of my own ancestors who survived enslavement, and knowing that people looked at the night sky and used it to self-emancipate in some cases. And so I think that there was a real need to recognize for me that honoring liberation work does not mean erasing people's curiosity, because actually, like, what I want to do is say that people in all kinds of conditions are curious about these questions. And so if I take that as a given that that is how a feature of how that works, and I listen to how people talk about how that shapes their lives, that also I start to recognize the political role that curiosity plays in their lives and the way that it motivates them to stay engaged and struggle because it helps them stay engaged with why should I try to live through this. And there are lots of different reasons that people try to live through this, that people decide to fight in peaceful ways, and also that people decide to fight in violent ways when they think that they need to. And they're often, sometimes it's their families, but sometimes it's, every university in Gaza has been destroyed, but the students have continued to try and earn their degrees despite being in those conditions. And that includes physics students that I've had exchanges with and been in communication with. So I think as I was writing this section, I was trying to record and mark the different places that my sentences came from in the timeline and acknowledge that these things were happening and trying to cinch together that there's something actually quite problematic about saying, how can we worry about physics when those people are facing genocide? Because there are physicists who are facing genocide who are worrying about physics and are trying to get out of the genocide because they want to have the opportunity to continue to worry about physics. And so there was a piece of like, I want to cinch together for people that these are not in opposition to each other, and that we should take care not to situate them as being in opposition to each other, but then start to think about like what's the opportunity there in terms of our understanding of what it means to create meaning and create meaning in our struggle and create utility in physics in our struggle for liberation for everybody.
I really appreciate you going into that depth and context here in this conversation because it gives so much additional uh, oomph to these through lines of the book. That curiosity, that curiosity as like a propulsion, as like the political role of movement that curiosity plays, comes up across the board in a lot of different books in a lot of different ways. And 'cause what I see, my job or what I feel like I do is really just looking at how ideas move in a community, move through books, move over time, how they evolve, just like watching them move is like just my joy and fascination on a micro scale in our town and further. And I was really fascinated on page 199 in the figure like 12.3, Michael Redhead's like drawing that you have there. It,
Yes. So that it's not actually Michael Redhead, I should say. Sharifa Williams did that, but it is inspired by from Michael Redhead's writing. Yeah.
I mean, I love a picture. I love the words because I equations I don't speak, but I'm wondering like if that particle, if this metaphor works, if that particle is an idea, would it be an applicable metaphor to say that books can do this, the way ideas move over time, appear, disappear, and reappear?
Oh, I think that's a really interesting question. And the thing that immediately comes to mind is Moby Dick, which is one of my favorite novels.
Tell me
Um,
more. Tell me more. But please, tell
I
me.
mean, so Moby Dick, like by the time that Herman Melville wrote Moby Dick, he was like an established author, but he actually had difficulty getting it published in the United States. And so it got published in the UK first, and it got published in the US eventually. And it got pummeled, like it reviewed really badly. And actually, like if you pick up a copy of, like maybe you can order through Country Bookshop a copy of the Norton edition of Moby Dick, you can actually read some of the reviews, which are just like brutal of Moby Dick. And it kind of destroyed Herman Melville, like spiritually, I think, that the book wasn't accepted. And it was really kind of the last big thing he tried to do. And then he kind of died a pauper. And like when he died, it was not particularly remarked upon. Like the way that Moby Dick is honored now in American culture, I think would have been totally unimaginable when he died. And then in the 1920s, really, I think he was recovered by book world people who were like, actually, this text has a lot in it. And in the very early 1950s, my grandfather wrote a book called Mariners, Renegades, and Castaways that was really about how Moby Dick is about American capitalism. And people started thinking about how Moby Dick was an allegory for white supremacy. And it became such an important text culturally that, for example, it was assigned to me as high school reading for the summer between 10th grade and 11th grade as I moved into honors English in 11th grade. That was one of the things that the honors English students were given for our summertime reading. And so I think that that's an example where that was in a book that was an idea at a particular moment and then kind of lay fallow for a while and wasn't really part of the culture, wasn't part of the cultural discussion, and then eventually reemerged in a different temporal location as a text of like great significance. And it's such an odd and beautiful book and hard book, but also one that is like deeply compelling. Even when there are parts of it, like I reread it and I'm like, this part's a slog. And then I'm like, I'm so glad I went through that slog. And so there's something like very powerful about that. And I think for me, it's become richer because I wrote a foreword for the most recent edition of Mariners, Renegades, and Castaways. And in prep for it, totally overdid it. They were like, you have 700 words. You don't even need to reread the book. And I was like, are you guys kidding? I'm going to reread the book and read 5 other books about it. And so actually, while I was writing The Edge of Space Time, I was also doing that reading and working on that piece, which is one of the reasons that a line from Moby Dick ends up making its way into the book. But I think also really shaped my thinking of, yes, if the thing is offbeat, let it be offbeat. And I think that that's, I know like Literary Hub said, what did they say about The Edge of Space Time? It was something like, Chanda Prescod Weinstein has something like an off-kilter curiosity. And I was like, that's it. It's off-kilter. And I think Moby Dick is a little bit like that. And I think in a sense, part of the work that that book does is give me permission to be off-kilter, right? And so I think that that's an interesting kind of metaphor of how I think another example of this that comes to mind is Zora Neale Hurston's Their Eyes Were Watching God, which is a book that I think disappeared from uh, cultural discourse after Zora Neale Hurston died. And then Alice Walker basically very forcefully in the 1970s was like, this is a book that you need to pay attention to. Zora Neale Hurston is a writer that you need to pay attention to. And again, that's, I think, a book. I might have gotten assigned that in high school or it might have been on a reading list. But again, it's a book that now people understand as one of being a great cultural significance. And that happens with books sometimes. And I think that that's one of the reasons the book world is so important is because like there is a kind of knowledge keeping element that comes with it. So I'm very interested in you seeing that kind of element of what the book world does in that figure. I like that metaphor.
Oh, well, I mean, this is where like, I mean, well, good. Because I was fascinated with, and you got this from a philosophy stack exchange website from them saying, which is conserved among interactions between things, um, which to me like makes me think of ideas as energy, and so much of what we do at the bookshop is really talk about not just ideas moving over time, but how like books are in conversation with each other. And one of the books that I really think is in conversation with your book is this book that came out. It's this little theory of art by Brian
Mm.
Eno and Bette, who are like super interesting. But it it just to me continues to fit into this the Michael Redhead thinking of how a particle moves. I'm going to show this to you, this little drawing, while I continue to ask my question. Um, but I'm just wondering if you can talk a little bit more about the activated and not activating, about energy existing in these fields are everywhere, but then they like turn on sometimes.
Yeah, I mean, I think, it was so interesting writing about energy, and I feel like this is a problem that I kind of think about on a daily basis, which is like how to talk about energy. Because I think energy is something that every single person has some kind of intuition for. But then also like I was actually like standing, this is something I do. I was standing in the shower yesterday and I was trying to figure out like um how I would explain to someone why. So we have something called kinetic energy. So kinetic energy is associated with motion. So I'm moving my fingers right now. So I'm converting like chemical energy from like my blood and neurological system into kinetic energy going into my muscles. And if I, in a very simple sense, want to describe kinetic energy mathematically, I would say it's the mass. So you can think of like the mass of my finger times the velocity of my finger, so how fast it's moving and what direction it's moving, times the velocity again. So it's, for those who are mathematically inclined, this is mv squared divided by 2. And so I can say that to you, and you can just sit there and look at me and be like, okay, I trust you. You have a PhD. I assume you're not full of shit, right? Um, and it's just like it's 1/2 mv squared. Like, okay. So I was trying to figure out like how would I justify to somebody that like that it has to take that form. And so certainly one argument that I can give, which I talk about in the book, is I talk in the chapter on quantum gravity about dimensional analysis. This argument of you have these dimensions that a phenomenon has to have. Like, that if something's going to measure a distance, that it has to have the units of length, right? So it's in meters or miles or centimeters or yards or something like that. And if instead you're looking at something and it's giving you units of time, like seconds or minutes, then that that's not a length. That's a time. That's a length of time. It's interesting because we say length of time, which is something I get into earlier in the book, right? So similarly, I have units for energy, and so I could just argue to you that the equation has to look like that because it gives you units of energy when you do the calculation. And that's it. Like, it gives you the right energy units. But that's not particularly satisfying, right? So I'm not going to attempt to justify why it's 1/2 mv squared for kinetic energy here, but I wanted to give that example to say that's the kind of problem that I'm solving when I'm talking about, like, how do I translate someone's sense of I'm tired or I'm feeling very hyper, right? From that to, we have these very formal definitions in physics that have like real meaning. Um, and then in particular, when you think about the presence of the electron quantum field being everywhere, but there are some places where there have been excitations in that field. And the excitations in that field mean that not only is there an electron there, but the nature of the excitation tells you what energy that electron has, right? And I think seeing that, even if you're like, oh, I don't really know how that works, I don't know if I feel like I always have like a very firm, and I'm teaching quantum field theory next spring, by the way. I'm teaching our graduate course. So this is something that I really have to think about in a professional way. But even if you're like, I don't know if that's really sitting in my brain the way that I like ideas to sit in my brain when I can claim that I understand them, I do think you have a sense of the layer, why physics demands abstraction from us and why it becomes important for us to make room for the abstract in our brains and in our lives. And I think that that is something that anybody can take away from it, even if they're never going to do any quantum field theory calculations. And so I think that that's like one of the pieces that's available to us. Um, but I do think I think of writing science for general audiences as puzzle solving, and I think that that's an example of like I need to solve the puzzle of how do I talk to you about kinetic energy without an equation, and that's not necessarily straightforward.
I mean, I love it because to me it makes total sense because it's like the excitation is like you reading a book and the idea like popping up in your brain and like the field of like but I'm like so off and into my own little thing. But I love I think you're a brilliant translator and
Thank you.
quite a gift to have your book. And it's a honor to highlight it. We're getting like close to the end of our time, and so I have my question. So a lot of so one of okay. Um there's a book that the Country Bookshop did. We did an interview with this author, Marcus du Sautoy, whose book Mathematics and Creativity is one that I had in my head coming to this book. And
Mm,
so did our Country Bookshop people who read that and joined us for that. And it really spoke to me about where you're talking about the classical world that we experience in everyday life emerging from the quantum world and that kind of movement of explanation. And so I'm going to go through this idea that I got from his book and then a couple ideas that I was introduced to through your book, and then I'm going to tell you what I think, and I need you to tell me
okay.
no, you're off. Yep, like I so I'm not leaving here with like a total incorrect understanding, which is
Okay.
highly possible. Okay. So somehow from reading his book, I got this idea that our universe is infinite and contained in like this this like donut image that's like sideways, like an infinity thing with like the middle of if this was sideways, that this is like the middle of the whole, and that it like functions in some sort of infinitely moving contained system. And then from your book, I'm, introduced to these ideas as I start at the beginning and go to the end that seem to like support this. So like the the Hawking and Herzog model on page 259, you say like a plethora of possible histories that must be used to establish the history of the universe. And these like pattern, he's talking about all these patterns over time, which makes sense. And then you talk about Julian Barber on page 167 in Taxi, this idea that like the universe isn't moving towards chaos, but is just like growing and moving towards complexity, which to me like makes sense as it's like getting bigger. And then you talk about on page 210 how dark energy has this history that has a different value in the past.
Maybe.
Maybe. Okay. Okay. So, but that it's like moving. And and then I see your picture on page 247, 15.1, that totally looks like a donut, the top down. Um, and I was
Ah, yes.
like, see, that's it.
The black hole event horizon.
Yes. And then on page 208, and you've talked about symmetry, they're like those figures. Just bear with me. Because I need you to tell me. It's not on page 208. Figure 13.2, wherever that is. And then you talk about how a black hole evaporates and all of its information is released into the universe. And would that like kind of fit in with that idea of it like regenerating in this cycle? I know that can I walk away holding that idea and and not be like completely incorrect? Because I am walking away with like these two books in conversation with each other with like that thinking, but I make things up sometimes.
So I think, I mean, I'm not sure. So are you saying like that infinity loop for you, is that a question of like, is the universe physically shaped like that? Or is that just like a schematic you have in your head that helps you think about how the idea, I'm not sure that I fully understand the picture or the role that that picture plays.
I think I am wondering like if on the outside of that donut, you know, you have the picture of the balloon going and the galaxy's getting further and further away, that would be like the outside of that donut, like growing sideways,
So
like
I don't, so I think like one thing that's like important to keep in mind is the difference between say that the book about mathematics, which I haven't read, so I have to
fair enough.
extrapolate a little bit. I am is that mathematicians think through scenarios that could be plausible given the right physical conditions. But physicists are tasked with thinking through scenarios that match our observed physical conditions. Yes,
So, so like the theoretical physicist versus the experimental physicist?
a
Or
little bit. So a mathematician can be like, I can come up with a solution to Einstein's equation where the following things happen. But to get that solution, you have to have the right boundary conditions, right? So I talk about beyond a cosmic boundary. I talk about this idea of boundary conditions. And so a mathematician can choose any boundary conditions they want, whether they're physically sensible or not. But the physicist has to worry about physically sensible boundary conditions, right? So that's our job. And so the universe that we live in, as far as we know, um, can be embedded, I think, because we're in an asymptotically flat de Sitter space, that the universe that we know could be embedded in a higher dimensional donut shape. But that would be like four spatial dimensions with one time dimension. So that's like a five-dimensional donut. It is not the case that our universe is shaped like a three-dimensional plus one time dimension donut. Um, and so that's something we feel fairly certain about. And the other thing that you kind of have to keep in mind is that you can embed, but what that means, like visually, it doesn't have visual utility because you can't visualize a five-dimensional donut, right? Um, and the other thing to keep in mind is that there isn't something outside of physically speaking, the universe by definition is the entire universe. So you can't embed the universe somewhere else because the somewhere else would be part of the universe. And so that's really what you're pushing on there is the edge of that visual metaphor with the balloon, which I talk about a little bit. It falls apart because the balloon metaphor invites you to think that the balloon is somewhere. But in the case of the universe, the balloon is everywhere because like the balloon constitutes the everywhere by definition. Um, so I do think that that's really the difference between like what a mathematician does and what a physicist does, and thinking about some of these the areas of math where they overlap is something called Riemannian geometry or differential geometry and topology. Is that topologists can kind of like think about in any type of scenario situation, whereas my job is always to think about a situation that helps us understand the universe that we actually live in.
what I love the most is that all of y'all are helping people who can just enter in any of these ideas through words and
Yeah.
metaphor to give up lay people or non-mathematicians and non-physicists the opportunity to imagine and think in ways that would never be open to people who don't speak those languages. And that is like the total gift of books. And my last question is about imagination. And one of my favorite books you reference and is and this is the last the that Ruha Benjamin Imagination and Manifesto. You have it down there
Mm.
um in a footnote. And I think your imagination comes through in this book. And I think you said LitHub called you like a quirky creative person, but I think it's brilliant. And I do nothing but read and look at books and look at what's coming out and has come out. And I think this book is really something truly special. And I have so many more questions, which I will not ask, but I really I'll have it available for like all of our people when I send this out to continue with. And is there anything else you want to kind of leave us about imagination or, well, actually, I will ask one more question because no, I won't. But thank you.
I,
Keep
yeah.
honest to your time. I wanted to ask about like the thing you referenced that was in your PhD. Um,
Oh, yeah. Um, I mean, I guess here's what I will say about that. So we talked a little bit about cosmic. You mentioned cosmic acceleration earlier, what's sometimes called the dark energy problem. We really do have this situation where the expansion of the universe is accelerating, and there's a debate as to whether we have solved why, like whether we have a full understanding of like why that's happening. And my for me, we're shaped by what are the abiding questions of our time. Like, what are people concerning themselves with? And it happens to be that cosmic acceleration was discovered right as I was about to graduate from high school. And so for me, that became like a very literally shaping problem that I pursued as an undergraduate. So I talk about this in the book. I joined Robert Kirshner's supernova search group because I thought that's how I would get at the problem. And then it turned out like actually looking at supernovae wasn't really like what made my heart sing. And so there was a lot of like figuring out. Um, and some of this was like getting an education in the details of when it's one thing for me to talk to you about these questions, and then it's another thing for someone to actually sit down and do the work. And you have to figure out what work is right work for you on a level. Like, I'm particularly in scientific spaces because you're going to get beat up by the science. I'm not even talking about the people. You're going to get beat up by the science because the universe is not designed to be easy for us to understand. And so sometimes it's hard. And so there is a piece of this that's like, if I'm going to get beat up by something, what's something that I love so much that occasionally, like, even though I'm mad at it, I want to come back to it. And so there was an element of continuously finding that. And eventually I landed at thinking about whether the presence of cosmic acceleration taught us something about what our complete theory of quantum gravity should be. And so that was essentially what my dissertation was about, was different ways of thinking beyond general relativity as we understand it as a way of resolving the problem of cosmic acceleration. And we now have some new data that suggests to us that maybe we actually do need to ask that question. I will say that the data is not solid enough that I will firmly claim, yes, we are certain that we're in that regime of needing to reformulate the problem. But we certainly have enough data that invites us to rethink it, that I think it's reasonable for people to be pursuing like a deeper understanding of that. It doesn't make me want to go back to working on the problem. Like, I think I worked on it long enough that I'm kind of like, I'm still not. I think if I get to the point where like I think of an idea where I want to chase that idea, I'll chase it. But I haven't been thinking about ideas and feeling like I want to chase it or anything like that. So, I mean, that's kind of where my relationship with it is. But it is, I think that whole situation is a reminder that a very exciting problem doesn't necessarily yield a very obvious or exciting answer on timescales that we would like it to. Because again, the universe isn't organized around us. And I think that that's very humbling and a powerful reminder that also when people are telling us, well, things just have to be a certain way, the universe doesn't follow human rules about how things have to be. It just doesn't. And I think, for example, as like we're looking at all of the awful like transphobia that's circulating out in the world, and you have people saying like, oh, well, you can only ever be whatever gender or sex you were assigned at birth. And then we have all of these people out here being like, actually, no, we constitute empirical evidence that that's not how it works. And like, yeah, that's the universe. It doesn't follow human rules.
I want to end on that. Thank you. And we're 1 minute over the exact hour, which I'm just so grateful for you giving to me and to us and for this book that y'all should all get from the Country Bookshop, The Edge of Space-Time, Particles, Poetry, and the Cosmic Dream Boogie by Dr. Chanda Prescod Weinstein. And just thank you. And I like your earrings. They look great for the book.
Oh, thank you so much. I think I usually wear them on the opposite side, but thank you so much for having me. And thank you to you and also to those of you who did stick around in the audience for your patience with the calendar disaster today. But I
It's
really
okay.
appreciate it.
Most people see it in a video later. So thank you. Thank you
I
all.
appreciate that. Take care.
Bye.
Bye.